We're back. Let's continue our collection of excerpts from the February Mount Baker Amateur Radio Club Digital Group's Zoom meeting. We've been listening to Steve, AG7GN, tell us about some handy backup utilities that he's written for the Nexus DR-X. He finished that topic and then moved on to an interesting one on peer-to-peer connections using PAT. PAT is an open source alternative to Windlink, which is a way of sending emails over amateur radio. PAT can run on most all platforms, whereas Windlink is pretty much a Windows-based application. We can run PAT on Linux, Apple computers, and even Windows computers. Basically, any computer that supports a web browser. So let's go back and find out what Steve has for us.
Next thing I want to show is a way to have peer-to-peer telnet capability with PAT. PAT is an open source alternative to Windlink. And what I have here are two browsers that are pointing to PAT instances on Linux servers that are both on AREDN. So the one on the right here is actually running on an Ubuntu Linux server at the SAR building here in Whatcom County. And this one is running on my on a Raspberry Pi that I have it here in my house. I have an AREDN node in my house, and I'm connected via internet tunnel to the AREDN mesh here in Whatcom County. So the way I have this set up, so what I'm going to, first of all, I want to make sure that people understand what I'm about to demonstrate doesn't use radios at all. There's no VHF or HF radios involved here. There's Wi-Fi, but there's no VHF or UHF radio. This is all done via Telnet, so there's no AX25 involved. So on the Linux server that's running in the SAR building, I created a service called PAT. This is something you can do in Linux. If you have a script or a program you want to run in the background all the time, you can create what's called a service. And you create a script that looks something like this. And you tell it how you want to start and stop your script. And basically it just starts PAT in the Telnet listen mode. You can see that it's listening on Telnet here. And it opens the, or activates the HTTP server that's part of PAT. So that's what I'm connected to here. So I'm connected to this on a browser on my Mac here at my house over the AREDN mesh and connected to the server that's in the SAR building. Okay, so this is always listening on the PAT Telnet port for incoming traffic. On this one, on this web browser here, this is connected to this browser is pointed to a Raspberry Pi that's also on the AREDN mesh, and it's here in my house. And right now it's not running. You can see the little red dot here that the PAT HTTP server is not running. The dot will turn yellow when it is running. Actually, it should turn green, but because this is not an SSL connection, Chrome and other web browsers don't allow notifications. So this will never turn green. It only turns yellow. Okay, so on the Raspberry Pi here, I have created a cron job that runs every 2 minutes. Maybe I'll just give a little background around cron. This is what my cron tab looks like, and a cron tab is a file that contains all of the tasks that I want the Raspberry Pi to run automatically at certain times. Okay, and lines that begin with a hashtag are just comments, so they're ignored. the way a cron tab is laid out is that there's certain columns. There's 5 columns here that you start with at the beginning of each line. And the first column represents the minute. So if I had a line that had 5 asterisks in a row, what that means is that I want this Raspberry Pi to execute a script or a program every minute of every hour, every day of the month, and every day of the week. That's if I had 5 asterisks. Now, if I wanted to do it every 2 minutes, every single day, then I do it like this. So */2, or every 5 minutes, it would be */5. And then I could specify certain days of the week, or a certain day of the month, or every other month, or you know, basically any combination you want. But I'm keeping it simple here, and I'm doing it, I'm running PAT in Connect mode, and I'm telling it to do a Telnet connection to this Telnet server. And this is the name of this Telnet server over here. So every 2 minutes, this client is going to connect to the w7ecg-web.local.mesh server, which is listening on port 8774 because I'm running it in the background here. Okay. Now, if I start my PAT instance here, I start my PAT HTTP server, all I need to do is type PAT -L. And I also want to listen on Telnet. I don't have to, but I can listen on Telnet and then start the HTTP server. That's really all you need to do with PAT in order to start it here. Or you can use the GUI in the Nexus image. The Direwolf PAT GUI will do the same thing. But I'm not using Direwolf here at all because we're strictly using Telnet. So I'll start the PAT instance, and you can see that my indicator up here turned yellow, meaning that the web browser connected to the HTTP service that's provided by PAT. Okay, so if I go here and compose a message and I send it to this call sign, WA7VMC, A7VMC, and test message, and 1, 2, 3, and I post that message, and I don't take any action because what just happened is it just disappeared automatically out of my outbox and appeared automatically in the inbox of the receiving station. That's because this cron job runs every 2 minutes. And then it delivered here. Okay. And then if I click this message and reply, and I say reply and post that, and I'll show it in my outbox and show this in show my inbox over here. When this cron job over here runs again, it'll create a Telnet session. And when that Telnet session is run, it will exchange any mail that needs to be sent from either station to the other station. So where might this be useful? So where this could be useful is in an AREDN mesh, or in an environment where you have multiple stations, one or more stations that need to send Windlink traffic or ICS 213 forms to one central station. Okay, couple of caveats here. This is a peer-to-peer connection. So if I were to create an email message here in this account under AG7GN and address the message to another station other than WA7VMC and posted it to my outbox, it would not send this message just by running this script. It will only send messages that are addressed to WA7VMC. Okay, it's not connecting to the general CMS server services that are offered by Windlink, and there went my message. As you can see, the cron job here ran, and my reply went back, and it appears over here on this PC, or in that browser. So what I was saying is that if it's a peer-to-peer connection, so if I created or composed a message here and sent it to another call sign and posted it to my outbox, and this script ran, it would remain in my outbox because it's not addressed to WA7VMC. Also, if it was addressed to WA7VMC and I added a second call sign or a regular email address, it will also not be delivered to W7VMC, even though it is addressed there. If there's more than one destination here, if it can't deliver this message to all of the destinations, it will not be sent from the outbox. That's just a couple of things I discovered when I was experimenting with this. So like I said, useful probably in an AREDN network or in an environment where you need to move ICS 213 forms, mainly like in if you have a remote headquarters and you have multiple agencies that are represented within Wi-Fi range of each other, all on a local Wi-Fi network or on an AREDN mesh. This might be a useful way to move ICS 213 forms to the command authority, whoever that happens to be. Any questions on that?
Oh yeah.
Okay.
So the peer-to-peer thing is established when you need to send the message. So more than one station could, for example, send messages to the same, like if we had more than one unit that needed to send messages to WC7SO, the WC7SO could get peer-to-peer messages from more than one unit. Isn't that correct?
Absolutely. Yep. It's listening all the time. So it'll listen to for any telnet connection from any other station that is addressed to W8 or WC7SO in the example you used.
Yeah, just to say it again, because I think it's important. Well, it's important to get widgy this into my brain. Is the peer-to-peer connection doesn't exist at all until there's a message that's being sent, and then it's dropped, so another one can hop in.
That's right. Yep. And in fact, it probably can handle 2 simultaneous sessions. So if I sent one here from AG7GN and you were on the same mesh as WB7FHC, and we happen to hit, and our cron jobs happen to occur at the same time, there's no reason why the listening instance of Pat here couldn't handle both incoming messages at the same time, provided they were both sent to WA7VMC. It's just like 2 people going to a website at the same time. That's, perfectly allowed. Okay, any other questions?
Then could there be something running at the destination, a program of some sort that when it received things, it would rebroadcast them to a selected group? Some sort of program that would, your cron job there would tell it, okay, the things I receive, I will send back out, I will broadcast back to the group of subscribers?
Yes, that's absolutely possible. It's not built into PAT. You'd have to write your own script to do that, but it's would be pretty easy to do. You just write a script to monitor the inbox, which is just a folder, basically. And if there's a new file that has appeared in that folder, you create a script that would basically run this command here, pat connect telnet. You could have a list of these, for example, with the other nodes that you wanted to forward a message to. And as long as all the other nodes, as long as all the nodes involved are listening on Telnet, like it's shown here and here, then they'll receive the message.
But to be clear, because we're using AREDN, if some of the nodes are linked via RF, it still works. It's still Telnet, but it's over RF.
Yes, if we're talking about AREDN using 802.11 or 2.4 gigahertz ham radio frequencies on AREDN, is that what you mean, Bud?
Exactly. Yeah. Some of the
exactly.
mesh is done with RF.
Correct. Yep. You can write the script. You can use a script like this, and instead of using the keyword telnet here, you can use, I believe it's AX25. I think that's the nomenclature they use. And then specify a station and a frequency here in this part. You don't use telnet, but you put a station and a frequency. And it will, if you have set up direwolf with push to talk, it will actually key the transmitter at whatever time you specify here and attempt to form a connection, a peer-to-peer connection with that other station and send it that way. So you're not limited to Telnet here. You can use any of the connection options that Pat has available, which includes RDOP. Doesn't include VARA yet, but it includes RDOP and AX25. There's one other mode too. I can't think of what it, Pactor. Okay, any other questions?
Is there a particular deployment mode that you would envision using this regularly on AREDN, or is it something you would turn up for an emergency?
I would envision that it would be something we turn up for an emergency. And we've not in Whatcom County, we have not used AREDN in any kind of MCOM capacity yet. Maybe someday, but we haven't used it in that way yet. But this is one application that could use that sort of setup.
And you probably are familiar with the Windlink Relay function, an additional application you can run on Windows?
Yes, correct. This functionality is available in Windlink as well. But since most of us are using Raspberry Pis, I thought it would be interesting to show how that functionality could be used on in Linux and in general in a Raspberry Pi in particular.
I raise it because we're thinking of hosting a relay in Seattle that would be available on a HamWAN IP address. And the Windlink Relay software will let other Windlink nodes, gateways, to fail over. So we're thinking of operating a centralized relay so that all of the other Windlink nodes that use HamWAN as a backbone can fail over to that relay in the event that the internet connection goes away.
Oh, very interesting. Now, I think that BPQ has that functionality, doesn't it?
It does. Each Windlink node can be configured with relay, and if it loses its internet connection, it then fails over to its programming or configuration really of its relay config, and it can be specified to relay through an IP address. So we're carefully kind of testing and understanding this before we announce it more fully. The thinking is we would host a node at the Seattle EOC, which is mostly designed not to go away in an emergency, we hope. And it has dual HamWAN connectivity. And the idea would be is any Windlink node also similarly connected to HamWAN as its IP connectivity could fail over there. And then for those nodes in Western Washington that have HamWAN connectivity, we could keep email flowing, using the standard Windlink protocols via HAMWAN to the extent that it stays up and the internet went down.
Would you make that available to any organization, EMCOM organization that happens to be on HAMWAN?
Yeah, I would think so. I think generally it's our goal to kind of share things around as much as we can, and it would make sense. Certainly, Camp Murray is on HAMWAN now as well.
Mm-hmm.
So I think our goal is to always make sure that Seattle is well connected, but also not only to Camp Murray and to King County, but to our neighbors too.
Very good. It sounds like your group, do you pass ICS forms over Windlink?
We do. So the Seattle ACS group has 140 members, and I think it's either 5 or 6 sectors that we operate in. Mm-hmm. So we have a kind of a tiered structure where a sector might be, for example, West Seattle, and then West Seattle has a team of maybe 5 to 10 amateurs that are processing things locally within that section of the city, and might have some messages to the battalion or the fire department that covers that area, but then would have messages they relay to the EOC. And then, of course, the EOC would manage if any of those messages need to be aggregated and the needs of multiple sectors joined together and then submitted to, in the case of Seattle, it can go direct to the state because it's a tier 1 city.
Oh, okay. Do you use FL Message and FL Digi at all to pass ICS forms?
Only for broadcast messages. So if the city, in our past exercises, we've used FL Digi to broadcast messages back out to the sectors. So rather than the EOC sending 5 separate Windlink messages, they'll just use one of our main repeaters and announce that they're going to do a broadcast bulletin and ask us to have our computers ready to receive it. And then we'll write down the bulletin, or if in the case we have a printer, we'll print the bulletin and hand it off to the city people or the hub people that are at the location.
Very interesting. Very interesting.
But we haven't discovered all the wheels yet, so we come and sneak on your meetings to learn what wheels you've invented. We'll take your best wheels as well.
Well, AREDN is fairly new to Whatcom County, and like I said, we haven't used it in any EMCOM capacity yet, but we are certainly kicking the tires